So this is QPSK. Just to keep the video short, I'll just explain the logic and what are all the things that are happening in this code. And I'll not explain what each and every function does. For example, I'll not explain what is CLC, what is clear all, what is close all. I can make a second video of it, or I'll just comment it and post it on the group, what all the functions actually do. So I'll just explain the logic over here. So let's begin. So for this QPSK, we'll start with the normal command CLC clear all and close all. After that, we take TB is equals to 1. Over here, TB is the bit rate. TB is the time that one bit of data needs to be sent. So over here, TB is equals to 1. That means one bit of data takes 1 unit of time. So 1 by 1, so 1. Now after that, T is equals to 0 to TB, TB by 100. That means we are having an array with 1 row and 100 columns. 1 row and 100 columns, or 101 columns to be precise. Over here, 0 to TB means 0 to 1 in 0 to 1 in increments of 0.01. So after that, after having a T, I'll explain later on why we need this T. So but just bear with me. This is T from 0 to TB, TB by 100. Now FC is equals to 1, frequency of the carrier is equals to 1. 1 kilohertz, 1 megahertz, it can be anything. Over here, it's 1 unit. After that, C1 and C2, two carriers. You must remember in QPSK, there are two carriers, one for even bits, one for odd bits. Over here, C1 is for odd bits, C2 is for even bits. I think so. We'll find out later in the code, if I'm right. Now, C1 is equals to square root of 2 by TB cos 2 pi fc of t, square root of 2 by TB sin 2 pi fc of t. Nothing to understand over here. It's just two carriers. Now in the book, in our lab manual, what they have done is they have plotted the graphs at the end. But it's better, I would suggest, to plot the graphs as soon as you find or you compute anything. Because if there is some error in this part of the code, you'll get to know it here itself. And if you don't do that, if you plot everything at the end and you get an error or you are not getting correct plots, you will not know which part of the code is wrong. So it would be better if you plot a thing whenever you compute it. So just plot the carriers. I've plotted both of the carriers over here. In the book, they have plotted the carriers along with the data after doing the QPSK, after actually modulating, after the modulation. So I would suggest just plot them first. Now C1, C2, subplot 3, 2, 1. You know 3 cross 2 का matrix होता है उसमें the first figure, right? Now the plot T, C1 against time. Here you'll understand why we did this thing. Now you can't take a continuous time over here. Maybe you can in MATLAB, but here we are not doing that. Here what we are doing, we are taking discretized time, but that time, there are so many iterations, there are so many periods from 101 that it appears to you as it is continuous. I'll explain just in a second. So if I run this code very quickly here, so you can see it appears to you as a continuous sine signal, but it is not continuous. It's only appearing to you as continuous only because of the resolution actually. So I'll tell you how. So if I just decrease the number of points, say if I decrease it to 10, then let's see how the figure comes. So you can see it over there. The figure is, you can actually see the difference, right? It appears less continuous, right? So now it's not continuous, even then it was not continuous. But the only thing was that at that point, your eyes can't actually figure out the difference. So that is why we do it. We find the time over here as 0 to TB in steps of 0.1. You can put anything over here, 2, 3, 4, 5, 6. But we are doing TB because we want to view only one byte. If I do more than TB, if I do say 2 over here, the graph will come only for TB, but it'll get elongated. The what you call it, the x-axis. The x-axis will be elongated. That's it. So now, because I have only 5 minutes for this video, so I'll move on. So let me just check how much minute. Okay, so the time is up. So guess what? You'll have to wait for the part 2.